This example involves essentially regression problem, and it is in the context of the Gesell developmental schedules. It is an experiment that was run at UCLA and published, and essentially the data are the following. There are 21 children here, and their age is given in months, age when they start talking. And then after, maybe during their teenage years or much later, they're taking this Gesell's test and getting the score on this Gesell test. This is Gesell adaptive score, which is aptitude test, measuring social adaptiveness and other properties, personal and social behavior. The better score, the better. These researchers were interested, is there any connection in the score of an adult and the time when this adult as child started to talk? So here we go. It is a regression problem, and the values of the score, yi, are regressed in the linear regression fashion against xi, which is time when, in months, when the child started to talk. And this is nothing special, very, very simple regression problem with single covariate xi. But we would like to see, is any of the observations yi unusual? And we are going to find conditional predictive ordinate, CPO, I for each of these yi's. To do this, we need to find the likelihood. For normal distribution, the likelihood is 1 over square root of 2 pi sigma and sigma square. And sigma square is variance, but we deal with precision. So this square root is given by this expression. E to the negative 1/2 tau, 1 over sigma square. And here is residual squared, yi minus mu I, the quantity squared. So simply, this is a nice way to represent the density here, but notice that here in density, the tau is parameter, and it will be updated from the posterior. And in this residual, this mu j would have 2 parameters, b1 and b2. So tau and r are random. Now, remember, inverse CPO of I is reciprocal of the likelihood, and we are going to save those. For the rest of the problem, we are going to give non-informative priors on the parameters and non-informative prior on the precision and run the program. So this is what we got. Here are the months when the child started to talk, and here are the scores, y. For each y, we found the inverse CPO, and we could not do inverses of this inverse within the same program. We have to go outside of Wimbugs and take reciprocals of those. Just get to the -1 and get CPOs. Now remember, CPO less than 2% potential outlier. CPO less than 1% definitely outlier. Let's see what we got here. We got one, number 19, which is definitely less than 1%. Number 19 is this. The child started to talk late, but score the highest, and that is unusual. Now we have here a child that started to talk very late in 42 months, but the score was really low. So that one is a little bit unusual, but bigger than 1%. So it is not outlier. So this is the way how you find the CPOs and look at the particular observations. Now you can put these CPOs as input in the new Wimbugs file and do the following. Remember, we need to calibrate the CPO of I with likelihood. So here I have CI, which is CPOI divided by FI. And that should be close to 1 with all well-behaved y's. But also, there are some functions applied on these CIs that will make this discrepancy from 1 more visible. Typical functions are CI log CI or negative log CI and so on and so forth. The MPQ, sum of ML CPOI, so this is the -2 log of CPI, which is almost deviance. So MPQ would be counterpart of the deviance calculated from CPIs. There are some other measures that you can produce here, but the bad news is that there is no calibration. You cannot really say except for the sort of agreement, let's say 2% possible outlier, 1% probable outlier. There are no ways to test this for being outlier, but at least you can sort of find the suspicious and interesting data points in your program. So here we go for number 19. All C's should be close to 1, but take a look at the 19. The C is away from 1, it is 88%. Also, if you have other measures, you have that the measure, let's say this G1 for 19th observation is away from other observations. Unfortunately, we cannot calibrate this. There is no test to say, well, that is significant. An MPQ is something that you monitor. You go to the node tool. Here is the info. In info, you will find the node tool. You will ask for MPQ. And for MPQ, you get value, which is essentially CPO version of the deviance.